Levi's. Welcome to the Math Universe. This is your gorgeous and mathematic teacher for today, Ma'am Nine. Oh, that's me, or Ma'am Janine P. Ragos. Mathematic teacher that could give you a new logic, knowledge, and information about mathematics. Are you ready on the lesson that Mom Nine could give? That's great! Prepare a paper and pen and get ready on our Math Universe adventure. Let's go!
The result of all possible outcomes in an experiment is called a sample space. And in this case, the sample space is either a head or tail. Let's have...
How about you? Can you try finding the sample space of tossing 3 coins? Let us find out!
Let us reveal the answer. If your answer is correct.
When we perform experiments, just like rolling a die, are we certain that the result will be an even number? If your answer is no, I agree with you. Though, there is a chance that it might be an even number, and a chance that it might not be an even number. These classic experiments that we did, tossing a coin, rolling a die, and even the activity on the last episode are chance events. Chance events because outcome is uncertain. A random variable is the result of chance event that you can measure or count. Many parts of our daily experiences in life are random. When we buy drinks at a food stall, how sure are we that we will get the same amount of liquid in our drinks as the others? Definitely, in this situation, there will be a slight difference in terms of the amount of liquid. Another, we feel the excitement for the results of the dice rolled when we are playing snake and ladder. We can also consider the number of cake ordered by each customer in every transaction. Random variables are not that predictable, but we can look at the outcome of the previous occurrences, which will somehow give us an idea of the behavior of random variables, like the activity of the previous episode. How true recreation or assimilation? Let us recall. Random variable is a numerical quantity that is assigned to the outcome of an experiment. It is a variable that assumes numerical values associated with the events of an experiment. A random variable can either be discrete or continuous. Let's focus on discrete random variable first. Let's have an example. Shakeverse is a mango shake business that offers mango shake or other beverages. The number of mango shake sold per transaction is an example of discrete random variable, since you can only get a whole number of mango shake, not half nor 1/4, but full. This means that discrete random variable is a variable which can only view a countable amount of values. Let's discuss some examples of discrete random variable from Shakeverse Mango Shake store situation. The number of customers who use cashless payment is discrete random variable because we can only get a whole number value for a random variable x, which is the number of customers. Of course, we cannot have a half for a number of customer. Even if a child is buying, the child cannot be counted as half, rather as one customer. Another example of discrete random variable is the number of days in a month where the store is closed due to pandemic situation. It is also an example of discrete random variable because we can only get a whole number value for a random variable x, which is the number of days. So let's recall where we identified from earlier discussion that the following examples are discrete random variable. The number of mango shake sold per transaction. The number of customers who used cashless payment. The number of days in a month where the store is closed due to pandemic situation.
This time, let's talk about continuous random variable.
Let's go back from Shakeverse Mango Shake store situation. If we want to get the amount of liquid in order of mango shake, it will take a range of values in milliliters. This is an example of continuous random variable. If we are interested how long it saves to create an order of mango shake or how long will a customer wait for the order, those are continuous random variable. Other examples of continuous random variable are the height of grade 11 students or the room temperature. So, what is really continuous random variable?
Continuous random variables that can take interminably uncountable number of potential values, regularly measurable amounts.
So, let's recall. We identified the following example of continuous random variable. First, the amount of liquid in an order of mango shake. Second, the time to create an order of mango shake. Third, the height of a grade 11 student. Fourth, the room temperature. All these are measurable amounts, and these are examples of continuous random variable.
Let's summarize what we know about discrete and continuous random variables. This means that discrete random variable is a variable which can only view a countable amount of values.
Continuous random variable can take any values within a range, including fractions and decimals, regularly measurable amounts. This time, let's see if you'll be able to identify whether a random variable is discrete or continuous. I'll give you 5 seconds to come up with an answer. So are we good? Activity time! Let's have our first item. Ready? The weight of a school bag. Is it discrete or continuous? If your answer is continuous, then your answer is correct. Weight is a measurable amount. Next item. Ready? Item number 2. Number of emergency calls in an hour from emergency hotline. If your answer is discrete, then your answer is correct. Number of calls is a countable amount. Let's go to our third item. Recording the distance traveled by the bus. Is it discrete or continuous? If your answer is continuous, then your answer is correct. Distance is a measurable amount. Let's go to our fourth item.
surveying about the number of cases due to COVID-19 pandemic in certain locality. If your answer is discrete, then your answer is correct. The number of cases is a countable amount. Item number 5. The number of promoted students at the end of the school year. Is it continuous or discrete? If your answer is discrete, then your answer is correct. The number of promoted students is a countable amount. Hope you did well with our activity. Do I hear 5? That's good. It means you understand random variable very well. Today had been a great learning experience. So, see you next time on the another Math Universe adventure in statistics and probability with Mom 9. Bye!